So today we're going to be talking about higher order derivatives. Okay, so basically we've been focusing on first derivatives just to get used to the rules. But now I want to talk about second, and then we'll talk about third derivatives and fourth derivatives and those later. Okay, but basically higher order derivatives is when you repeatedly take the derivative of a function. Okay, so for instance, this first example says find the second derivative of y equals x to the fourth minus 2x cubed plus 6x. So to find the second derivative, I need to first find the first derivative. So the derivative of y is y prime. So we differentiate both sides. And the derivative of x to the fourth is 4x cubed minus 6x squared plus 6. So this is the first derivative. Okay? But I'm looking for the second derivative, so we're going to take it again. So the derivative of y prime is y double prime, and we do the same thing again. We do power rules. So 3 times 4, that's 12x squared minus 12x, and the derivative of 6 is 0. So this is our second derivative. Okay. Now we'll get into later about what each one of these means, because this is the slope of this, but the second derivative also will tell me a lot of information of my original function as well. Okay, and we'll get into more of that next time. All right, so that's one way of asking for the second derivative. Now, here's another example. I have if f of x equals x squared sine x, then find f double prime of x. So again, it's asking me to find the second derivative. Well, again, to find the second derivative, I need to first find the first derivative. So in this example, f of x equals x squared sine x, the main rule I'm going to be using is I actually have a product rule going on here because I have x squared times sine x. I don't need to rewrite, so I can go ahead and just take the derivative. So f prime is equal to the derivative of the first, 2x sine x, plus x squared times the derivative of sine, which is cosine x. Okay, so here's my first derivative. Now normally before we would take the second derivative, we'd simplify anything if we could to make our lives easier, but for this one, it's really, there's nothing I can do to simplify it to make it any easier on myself. So I'm going to go straight into taking the second derivative. So f double prime of x, the derivative of the derivative. But this time, I'm going to actually have product rule here and product rule there. So here we go. We now have to take the derivative of this one doing product rule. So the derivative of 2x is 2 times sine x plus 2x times the derivative of sine, which is cosine x. So this is the derivative of the first one. Okay. Plus, now we take the derivative of the second one. And again, we're going to do product rule here. So the derivative of the first, which is 2x times cosine x, plus x squared times the derivative of cosine, which is negative sine x. And this one here, all of this is the derivative of the second one. Okay? So here we can see that we've got some simplifying we can do. Okay? Again, we're still following our four rules. So we took the derivative, now we simplify. So f double prime of x is 2 sine x. Then we have 2x cosine x plus 2x cosine x, which is 4x cosine x, minus x squared sine x, because the negative makes this negative. And here is our second derivative. So you can see sometimes when you take a derivative of a derivative, you're going to end up having multiple rules going on in the same problem. Okay, so let's do one where it's quotient rule. Okay, so again, here's another example of a way I can ask for the second derivative, d squared dx squared of this function. So again, it's asking me to take the second derivative, but I need to find the first derivative first. Okay, so d over dx of x cubed plus 3x squared over the square root of x. Now, there's a bunch of different ways of doing this. You could straight up do quotient rule, okay? And you could do, this is the high, that is the low function, you could do quotient rule. But I'm going to use some algebra to simplify again. So I am going to, again, use my rules and I'm going to rewrite. So I'm going to get x cubed plus 3x squared over x to the 1/2 power. So I changed my square root to the 1/2 power. And now I'm going to do some algebra and simplify and say, okay, now I'm going to take the derivative of this function simplified. Now, when you have two things with the same base and you're multiplying, you add the powers. If you have two with the same base and you're dividing, you subtract the powers. So what I'm going to do is rewrite this so you can see it. And I'm showing all my steps. Normally I wouldn't have to show all of this, and it would be a lot quicker. But I separate it, and now I'm going to subtract powers, and this is going to be x, and that's going to be 5/2 plus 3x to the 3/2. So 3 minus 1/2, that's 2.5, and 2 minus 1/2, that's 1.5. So before I even started, what I did is I used some algebra to simplify to make my derivative taking a little bit easier. Okay? So now I can take the derivative. So again, move this out front, subtract 1 from the top, and you get 3/2 plus 3 times 3/2, that's 9/2 x to the 1/2. So that's the first derivative. Okay, so I've basically taken the first derivative. Now we're going to take the derivative of this one. Again, d over dx of this one. And again, I'm just doing simple power rule. So I move the 3/2 out front. So that's going to be 15 over 4x to the 1/2. Because move that out front, 3/2 times 5/2 is 15 over 4. And then again, do the same thing here. Move the 1/2 out front. You get 9 over 4. Subtract 1, you get negative 1/2 power. And this is the second derivative. And again, we wouldn't leave it that way. We would basically change this to 15 over 4 square root of x plus 9 over 4 square root of x. And that is our answer. So if we had done quotient rule, and I really don't want to go through that with you guys, but if we did quotient rule, we would have ended up with another quotient rule. And then when we took the second derivative, it would have been a mess because you would have ended up having to do quotient rule twice. But you would have ended up something like that, like this at the end.